Today's lesson is measuring segments. Take a minute to read your learning goal, find where you are on the scale now before the lesson, and rate yourself. The ruler postulate says that every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on a line and real numbers. The real numbers are called the coordinates. The ruler postulate allows you to measure the lengths of segments using a given unit and to find the distance between the points on a number line. If you look at line AB, the distance between point A and point B is the absolute value of the difference, subtract, of the coordinates. So here I would write the absolute value of A minus B. This value is called the length of segment AB, or you can write the length of segment AB this way. In example 1, we will measure segment lengths. The question is, what is the length of segment ST? Here is segment ST. It starts at point S and ends at point T. Since the coordinate of point S is -4 and the coordinate of point T is 8, we will take the absolute value of the difference of these two coordinates to find the length of segment ST. Since -4 minus 8 is -12, we will take the absolute value of -12, which is 12. So the length of segment ST is 12 units. Note that we can also count. From point S, we'll go 2, 4, 6, 8, 10, 12 units to point T. Pause the video and do you try number 1. Let's check your answer. Here we want to find the length of segment UV and the length of segment SV on the number line. So let's start by finding segment UV. Segment UV starts at coordinate 10 and ends at coordinate 14. Let's take the absolute value of the difference to find the length of segment UV. 10 minus 14 is -4. The absolute value of -4 is 4. So the length of segment UV is 4. Now, let's take a look at segment SV. Segment SV starts at point S at -4 and goes to point V at 14. So we'll start with the absolute value of -4 minus 14. That will be the length of segment SV. -4 minus 14 is -18. If I take the absolute value of -18, I get 18. So the length of segment SV is 18. Let's take a look at the segment addition postulate. Here, if you have 3 points, like point A, B, and C, that are collinear, and B is between points A and C, then the segment AB plus the length of segment BC will equal the whole length of segment AC. Here are a couple of examples of how to set up the equations. Let's use the segment addition postulate to find the lengths of segments EF and the length of segment FG if we know that the length of segment EG is 59. We know that this segment EG, is 59 units. We also know that the length of segment EF plus the length of segment FG will equal the length of segment EG. Let's write that equation. Now let's substitute 8x minus 14 for the length of segment EF and 4x plus 1 for the length of segment FG. Last, we'll substitute 59 for the length of segment EG. Okay, 8x plus 4x is 12x, -14 plus 1 is -13, and that will equal 59. Let's add 13 to both sides, and we get 12x equals 72. If we divide both sides by 12, x will equal 6. In order to find the lengths of segment EF and FG, we will substitute 6 in for x for both of these expressions. 8 times 6 is 48, minus 14 is 34. The length of segment EF is 34 units. For the length of segment FG, 4 times 6 is 24, plus 1 is 25. The length of segment FG is 25 units. To make sure that we're correct, if we add 34 to 25, we should get 59. Since we do, we know we've done a good job. Go ahead and pause the video and do you try number 2. Okay, let's see how you did. Here, they tell us that the length of segment JL is 120 units. We want to know the length of segment JK and the length of segment KL. Well, segment JK's length is 4x plus 6, and segment KL's length is 7x plus 15. Let's start by writing a geometry equation. Now, let's substitute the length of segment JK here, the length of segment KL here, and the length of segment JL here. Now let's solve for x by combining like terms and isolating the variable. We know that 4x plus 7x is 11x, and we know that 6 plus 15 is 21. That will equal 120 units. Subtract 21 from both sides, and 11x will equal 99. Divide both sides by 11, and x will equal 9. To find the length of segment JK, we want to substitute 9 in for x in JK's length. To find the length of segment KL, we want to substitute 9 in for the length of segment KL. The length of segment JK is 4 times 9, or 36, plus 6. 36 plus 6 is 42. So JK's length is 42 units. The length of segment KL is 7 times 9, or 63, plus 15. 63 plus 15 is 78. To make sure that we are correct, we know that 42 plus 78 should equal 120. Since it does, we are correct. When numerical expressions have the same value, we say they are equal. Similarly, if two segments have the same length, then the segments are congruent. Notice here we know that both of these segments have a length of 1 inch, so their lengths are equal. The length of segment AB is equal to the length of segment CD. Over here we do not know the length of segment AB or CD. However, these tick marks tell us they are congruent. So we would say segment AB is congruent to segment CD. Okay, let's compare segments. Are segment AC and segment BD congruent? Here's segment AC and here's segment BD. Let's start by marking them. AC starts at coordinate -2 and goes to coordinate 5. So remember, the absolute value of the difference of -2 and 5 will be the length of segment AC. Since -2 and -5 is -7, the absolute value of -7 is 7, the length of segment AC is 7. If you look at segment BD starts at point B at 3 and goes to point D at 10. So we'll take the absolute value of 3 minus 10 to give us the length of segment BD. Since 3 minus 10 is -7, the absolute value of -7 is 7. The length of segment BD is 7. Since both segments are 7 units long, segment AC is congruent to segment BD. Go ahead and pause the video and do you try number 3. Let's check your answer. Is segment AB congruent to segment DE? Well, here's segment AB. It starts at point A at coordinate -2 and it ends at point B at coordinate 3. Let's take the absolute value of the two coordinates, -2 minus 3, and that will give us the length of segment AB. -2 minus 3 is -5, and the absolute value of -5 is 5. So the length of segment AB is 5. Now, let's go over to segment DE. Segment DE starts at point D at coordinate 10 and ends at point E at coordinate 14. Taking the absolute value of the difference, so 10 minus 14, will give me the length of segment DE. Since 10 minus 14 is -4, if we take the absolute value of -4, segment DE is 4 units long. Since 5 and 4 are not equal, we would say that segment AB is not congruent to segment DE. In the reasoning portion, they want to know if we subtracted -2 from 5 instead of 5 from -2 in problem 3, would we get the same length for segment AC? Well, let's see. Here, if I take -2 and I subtract it from 5, I'm still taking the absolute value. I'm going to add when there's a double negative. So 5 plus 2 is 7. The absolute value of 7 is 7, so the length of segment AC is the same as before. The midpoint of a segment is the point that divides a segment into two congruent segments. A point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect that segment. The point, line, ray, or segment is called a segment bisector. Here, segment AC's midpoint is point B. Notice the two tick marks on segment AB and segment BC. Line L, since it crosses segment AC at point B, the midpoint, line L is the segment bisector. Example 4 tells us that point Q is the midpoint of segment PR. That means that segment PQ is congruent to segment QR. So let's start by writing that equation. Next, let's substitute 6x minus 7 for the length of segment PQ and 5x plus 1 for the length of segment QR. Now, let's go ahead and solve for x. If we subtract 5x from both sides and add 7 to both sides, we will end up with 1x equal to 8. So x is 8. To find the length of segment PQ and segment QR, let's substitute 8 in for x in both of these equations. 6 times 8 is 48. 48 minus 7 is 41. So the length of segment PQ is 41. Now, let's look at segment QR. Segment QR has a length of 5 times 8, or 40, plus 1. So the length of segment QR is 41. Since they are congruent, we know we've done a good job. They've also asked for the length of segment PR. Segment PR is the length of segment PQ and the length of segment QR. If we add the length of segment PQ to the length of segment QR, 41 plus 41 will give me a length of 82. So the length of segment PR is 82. Now pause the video and do you try number 4. For part A, it is not necessary to substitute 8 in for x in the expression for the length of segment QR because we've already substituted 8 in for x in the expression for the length of segment PQ. Since Q is the midpoint of segment PR, we know that segment PQ has the same measure as segment QR. Therefore, both segments have a measure of 41 units. For part B, point U is the midpoint of segment TV. That means that segment TU is congruent to segment UV. Let's start by writing that equation. Next, let's substitute 8x plus 11 in for the length of segment TU and 12x minus 1 in for the length of segment UV. Let's subtract 8x from both sides and add 1 to both sides. This will give us 12 equal to 4x. If we divide both sides by 4, 3 will equal x. To find the length of these three segments, we need to substitute 3 in for x into one of these two expressions. Since both of these segments have the same length, we only need to substitute x in one time. Then we can add the total length to find the length of segment TV. 8 times 3 is 24, plus 11 equals 35. Since the length of segment TU is the same as the length of segment UV is also 35. We know that the length of segment TV equals the length of segment TU plus the length of segment UV, or 35 plus 35, which equals 70. Complete the lesson check now, then move to the next slide to check your answer. How do you do? If you miss anything and you aren't sure why, make sure to ask me tomorrow in class. If you're feeling like you really understood this lesson, go for the challenge. Now where are you on the learning scale?